one is R, the other is S. If one is R, the other has to be S. If one is D, the other has to be L. One is plus, the other has to be minus. One is capital D, other has to be capital L. Alright, so these are the things which we have got to keep in mind. Alright, so now what are those? Let us understand one by one. Alright, so let's talk about R and S. R stands for rectus. R-E-C-T-U-S. R stands for rectus. S stands for sinister. Alright, so rectus and sinister. Now what are those? Let's understand. Now see, whenever you are talking about these atoms attached, fluorine, chlorine, bromine, iodine, these are halogen series. I have just taken simple atoms to make you understand. Now, when you see these atoms, they are all halogens. Fluorine, chlorine, bromine, iodine. Now I have put in size over here. We know iodine is the largest, bromine slightly smaller than, Cl slightly smaller, and F is the smallest. So F is the smallest molecule. What we are concerned is with LMS, that is large, medium and small. Alright, so now let us assign which is the largest, which is medium, which is small, and which is the smallest. Alright, so if we analyze, F is the smallest. So what do we do with F? We take F behind. So if this is the molecule, suppose this is F, I'll take F behind. Alright, so F is the smallest, so assume that this is F. Alright, one which is behind is F. Now this is Cl. Alright, this is Cl, and this is Br, and this is I. Alright, this is Cl, this is Br, this is I. Cl, Br, I. Got this? And the smallest one, we always take it behind the molecule. Done. Now what happens is, now we assign it in terms of LMS. Iodine, we know is the largest, so I put in L there. Bromine is medium amongst the three. Bromine is medium. And smallest is Cl among these three. Otherwise smallest we take it behind. So large, medium, small. I assign it like this. And then what you have got to do? You just have got to make an arrow from LMS. LMS. That's what I did. I made an arrow. Now when I made an arrow from LMS, it moved towards right direction. The arrow was towards the right direction. Now since it was towards right direction, so we call it as R isomer. Alright, rectus, R isomer. Now let's check out here. Now this is the mirror image of that. Alright, now since this is the mirror image of that, again let us check out. This is L, this is M, this is S. Now if you draw LMS, it comes towards the direction is towards left. Here the direction was towards right. Here the direction of LMS is towards the direction of arrow drawn from LMS is towards left. So we call it as S or sinister. It's twin. Alright. So this is mirror image of that. Now something interesting I would like to just say. Now my field, my scientific field have been into synthesis of chiral molecules only. Whenever we try to synthesize one of this molecule, we always end up with both of it 50-50. Whenever both the molecules are present in ratio of 50-50, we call it as racemic mixture. What is racemic mixture? Racemic mixture is 50 of this, alright, 50 of R and 50 of S is racemic mixture. Whenever in lab I try to synthesize single optical isomer, I end up with racemic mixture. Now another word that we use for optical isomers is enantiomer. This is yet another term that we use for optical isomer, that is enantiomer. So these two are optical isomers or these two are enantiomers. Alright, some call it as enantiomer. Alright, choice is yours. You can pronounce whichever way. Alright, so I hope R and S we call it as configuration. R and S configuration is clear to you. So R, very simple, write R. LMS directing towards right, R. Alright, so obviously the other one, when left, it is S. Alright, so we are done with this.